All right. Thanks everyone for coming. Welcome to this afternoon's discussion on demand flexibility from the customer's perspective. I hope you had a good lunch and you're ready to actually listen, not sleep, but we'll take it. Can't hear? What about now? Now? Okay, they like it close. All right. So I hope you all had a good lunch. We're going to be talking about demand flexibility from the customer perspective. I'm going to use the term load flexibility today because that's the term I prefer, especially for everyday demand side flexibility. What we need to do is work with customers to design effective dynamic rates and flexibility programs that meet them where they are and reward them for automatically shifting electricity use away from peak hours when electricity is expensive, polluting, and constrained to times when electricity is cheap, clean, and plentiful. So everyday load flexibility guided by hourly dynamic rates and programs has the potential to save the people of California billions of dollars in grid upgrades and generation. So we often don't think as much as I think we should be thinking about customers. Solar panels generate electricity from sunshine. The people of California are the power source behind demand flexibility. To make the most of this renewable resource, we have to partner with the customers to design rates that work for them and reward them for providing load flexibility. To help make this a reality, the CEC has adopted the load management standards back in 2022 that require the large utilities in California to work towards providing their customers with an opportunity, the option, to enroll in hourly dynamic rates. And the CPUC is working with the big three investor-owned utilities to make this a reality. So customers also need devices and appliances to do a lot of the work of automating load flexibility for them. I think there's very few people who will sign up for an electricity rate that varies hourly without knowing that they have some means of responding to those rates. The flexible demand, now I gotta back off. The flexible demand appliance standards team at the CEC is working on standards that will ensure that many appliances will be able to automatically schedule electricity use for customers. So for today, I'm going to stick with the term customer. As you all know, that's not really true anymore. Our homes and businesses don't just purchase kilowatt hours of electricity. We also schedule, generate, and store electricity. For this reasons, we'd have many attempts at terms, including demand side, load, prosumer. I actually think we should call the people who are participating in the energy system, who we have historically called customers, I think we should call them partners and treat them with that respect. So, dynamic rates and customer-controlled load flex are also resilient to policy changes. Once you have the rates established and you have the load flex built into people's homes and it's automated, it's really hard to undo that with policy. So if we move in the good direction, it should be sticky. Now, I think everyone can be partners in ensuring that our electricity system is affordable, reliable, and resilient. Remember that we're not solely customers and that our relationship to energy is not solely demand. We have these solar panels and batteries that generate electricity and store it for later. We have appliances that schedule when to operate, EVs that schedule charging. All this can be used to provide load flexibility for the grid and bill savings for customers. This all makes our electricity system cleaner and more reliable. We have lots of ideas for how to do load flexibility, how to do demand flexibility, and we probably need all those ideas. We should be working together, but we can take multiple pathways there. So here to talk about load flexibility from the customer perspective, we have 5 expert panelists. They'll introduce themselves, but to begin with, we have Bruce Nordman, Jomo Thorne, Achintya Madduri, Keith Graeber, and Mitch Sears. Please welcome them. So I'm going to start by passing this off to Bruce Nordman, scientist at LBNL.
Okay. Thank you very much for being here. My work for the last few decades is focused on the intersection of internet technology and electricity systems. We've dramatically transformed globally a core area of our lives in technology communications, and replaced our 19th century phone technology with something much better, internet technology. And we need to accomplish a similar sort of transformation for our electricity system, and we absolutely need to learn as many lessons as we can from that earlier transformation and apply them to the present and future. So is my slide available? So I absolutely agree with the framing of having the customer-centric, because we constantly have to remind a lot of grid people that the purpose of the electricity grid is to serve customers, not the other way around. And so I think customers and customer devices should really drive how we design our better future. And in working through this, I've looked for what mechanism can be analogous to the internet protocol of being the fundamental mechanism that drives electricity systems in all countries and all building types, at all scales and all application contexts. And there's only one mechanism that can possibly serve that, and that is pricing. Other mechanisms are all more expensive and lower performing. So just like we have energy efficiency at the top of our loading order for supply, we should have pricing at the top of our loading order for flexibility. And the Energy Commission has recognized that, and most of the 7 gigawatt goal is to be from pricing as is appropriate. Now, I know it's not kind to criticize your hosts, but I did notice on the agenda for today, we have a lot of panelists who represent aggregator companies, and we have very few panelists who have the customer at the center and pricing at the center, like myself. And I hope the next year things are different. Aggregators are terribly important. We need them to fill around the edges where pricing doesn't accomplish things, but they should clearly be secondary to pricing. So one of the main barriers we have towards progress is there are a lot of things which were absolutely true in the past, but are no longer true today and are incompatible with the better future. And I have a long list of these things. I'm not going to go through it right now, but we've already made lots of changes in how we think about things. We went from efficiency being not part of utility and grid work to being part of it. There's lots of changes we've made over time in terms of the grid following demand, and now demand following the grid. We need to make a lot more of those changes in our thinking in order to move to a better future. So I was very pleased that Josh Becker mentioned capacity issues. There are people, the grid in Australia coordinates with customer devices today to manage distribution system capacity. That's present in standards. We could readily implement it very soon. We just have to recognize there are solutions that revolve on communications and control that can substitute for expending lots of capital on the distribution system, which can dramatically raise the amount of it that we use without adding additional hardware cost. We absolutely need to leverage that as a complement to manage with pricing, because while pricing can reduce distribution system issues, it cannot eliminate them. Therefore, we need to manage capacity. And 33 years ago, USB was introduced. USB has capacity management. All we need to do is take a mechanism present in devices that we already own, scale it up to the level of a building, and move into a better future. So internet technology is the same everywhere. You go anywhere on the planet, Ethernet, Wi-Fi, web browsing, email, they're always the same. They're simple and they're universal, and that's what makes them low cost and high performing. We need to apply those similar principles to electricity systems. Complexity is the enemy of progress in this area. And we need to drive out complexity wherever we can and make sure that the hourly prices we have offered in 2027 are as simple as possible and do not include unnecessary and counterproductive complexity. So again, those would be if we adopt the principles that things should be simple and universal, we're 80% of the way there. Thank you.
Thanks, Bruce. Now we're going to Jomo Thorne, and let me know when you want to switch slides.
So good afternoon, everyone, and thanks for your attention after lunch. It's great to be here. I'll say this, what's really great about today for me has been the energy in the room and the feeling that there are so many different stakeholders who want to do something about the issues we face. And if we can figure out how to work together, we can get so much done. So I'm really excited about the opportunity to have dialogue with everybody here on these ideas. So, and especially to talk about the customer and the customer experience with demand flexibility. So I will say that for PG&E, the customer experience and the cost are central to how we think about these issues. So for instance, we know that demand flexibility gives us an opportunity to engage customers in different ways, in new ways. And so that means that we have to pay attention to the customer experience. But are we able to make it easier for customers to participate in any measure? And also, how well do we communicate the value proposition to the customer? How do we help them understand the value for them? And also get feedback from customers to understand if what we think provides value actually providing value, right? So, for PG&E, for us, we are very excited and supportive of the initiative on hand right now. Our goal is to have a decarbonized, clean energy future, but with rates that are lower than they are today. So the key for us is that we support the efforts that are underway here, but we don't support them regardless of cost, right? So we have to find a way to use light flexibility to reduce or postpone expensive upgrades in our system and for buying additional supply. And so if we don't do that, if we build all these load flexibility programs and options and rates, and we don't actually have a reduction in what we're spending on our infrastructure and our supply, then we're just adding more cost to customers, right? So we have to be very conscious of the customer cost and impact when we think about the work we're doing. I will say that, definitely in my experience working with demand response and working on many different programs, developing a streamlined customer experience is so critical for the success of getting a customer from hearing about an option to actually getting enrolled in it. Right now, because of the challenges we have with data access, with different rules for different agencies, then when we try to develop a program for customers or programs for customers, oftentimes we don't get the full value of the program because it's so hard for the customer to get into the program. So one thing I want to highlight is that we at PG&E have basically looked at exploring what kind of signals are the signals that would get customers to respond. And one thing I want to highlight is, notwithstanding the value and the promise of pricing signals as a way to communicate and to entice and move customer behavior, that's not the only signal that we should consider. There are other signals that actually could be just as effective for customers. So for example, and I'll talk about this in a little bit on some of the pilots that we're running, but instead of sending just a price signal, can you send a load shape? Can you say, given where your customer is sited, given the constraints that we see in the field, we propose or we asked you to modify your consumption or your export and so on in a certain way. So load shapes is really important. And the signals, any signal we send, whether it's pricing or load shape or something else, they have to really consider and harmonize the grid needs and the customer needs and abilities to perform. So we've launched a few pilots at PG&E that focus on different aspects of the energy management and utilization process, and also explore different ways to deploy load flexible resources. But the key thing for us are that the resource has to deliver firm capacity. Second, that the delivery benefits both participating and non-participating customers. And lastly, that again, we don't just focus on price signals as the only way to convey or to modify behavior. There are other ways in which we can do the same. So real quick, I just have 3 examples I want to share with you about some pilots that we've been running. So first is the flexible service connection, the Flex Connect. So basically, this allows customers who have controllable loads and who want to connect to the system, allows them to do so. And the system that is in a grid that's constrained, if they want to be in that system, then this allows them to actually connect to the grid earlier than they otherwise would have to. We've seen that it unlocks a lot of value for the customer. So it helps both the participating customers and non-participating customers by getting us firm deliveries. And also, this is one of the ways in which, as we run these programs and these options, we can gain credibility with our planning folks. So they're folks who actually have to do the planning for on the distribution side, on the transmission side. If they don't believe that the load flexibility is actually real, they're not going to consider it in their planning efforts. So for us, this is a great way to actually demonstrate that we actually can get reliable load if we give the customer the right incentives and signals. Next one I want to highlight is the EV Charge Monitor program. So this is an epic pilot that we launched this year, partnered with Weebrid, where basically we optimize the EV battery charger to prevent overloads during the times where they're going to break our transformers. So in other words, a system that's optimized today for TOU, that means the system will start charging at midnight, right? Because that's when the off-peak begins. And if we have all the chargers in the area charging at the same time at midnight, that's going to be a problem down the road for the affordability of our resources. So the idea is that with the partner we have and the software we're using, we spread out that charging behavior throughout the off-peak period, not just have it all at the same time. For us, what our hypothesis is that by doing this, not only do we give customers a chance to engage and provide their load, but also that we're also able to extend the life of our equipment. And the last one I want to highlight, next page, is the seasonal aggregation of versatile energy, or SAVE. So this is another epic pilot that we launched this year. In this pilot, we basically customers in aggregated DERs can respond to a proactive load shape on the distribution circuit. We send this load shape to the customer, to the device, in a day-ahead basis, sometimes a week ahead, depending on the customer and the location. With this program, we use both batteries and smart panels to convey signals. We potentially might expand to other types of devices, but for now, that's what we're doing. So we are testing this on about 16 feeders right now, partnering with Sunrun and NextEra to test if they can control their devices based on a load shape. So I wanted to share these really quick because, again, it's not, there's many ways in which we actually can, skin the cat. I think that's a phrase, right? So there's, it's not just price signals, there's behavioral modification incentives. And one last thing we got to think about is there's actually a lot of customers out there who could participate, who have load to share. We just have not set up the right economic market infrastructure for them to do so. So, for example, we have a lot of programs that are easy for aggregators to bring customers to. In some areas, we're getting a lot of customers that are, residential or C&I and so on. There are, and I hope I'm not stealing his thunder, but there are thousands and thousands of buildings out there that have energy management systems that are not being leveraged for demand response or for load shifting that actually could do a lot more for the grid. So, part of what we have to do is do a lot more customer research. So we, create design programs and we talk amongst ourselves, and we have a certain perspective and expertise, but we don't necessarily go and talk to the customer and understand what is their elasticity. What are they willing to do with what device under what conditions, or with what rate under what conditions? So that's the last thing I want to mention, that's something we have to really build into our program and our work more in the future. Thank you.
Thanks, Jomo. Next, we have Achintya Madduri. He's Senior Analyst at the CPUC. Thank you.
Thanks, Steph. And thank you very much for having me here. So as Steph mentioned, I'm a Senior Analyst at the CPUC. I'm a member of the Retail Rates team at the CPUC. And our core function is overseeing and regulating the retail rates that are offered by utility companies. And I want to stress a little bit about the importance of rates, because I think we focus a lot about how rates can send signals, can incent behavior response, and yes, they can, and that's a really important function. But the other important thing about rates, and I think this is worth stressing, is it also apportions costs fairly. And that fairness angle is really important. And I think we shouldn't lose sight of it. And it's really important about costs of the grid being reflected in rates, because yes, they can send the right signal, but even if they even if the response isn't exactly as predicted as you may want to do through imputing elasticities, the other aspect that's important about cost-reflective rates is the people that are imposing costs on the system are fairly paying their share. And I think this is something that we are holding as a very important value. We've adopted cost causation, economic efficiency as a core part of rate design principles going forward, because we want to take all of our rates, not just the TOU rates, but also the future dynamic rates, in a direction where they send strong signals and then they fairly recover costs from the people who may not respond to those signals that are being sent. But focusing specifically on dynamic rates, there's a few years ago, 2022, the CPUC's retail rates team and demand response teams released a white paper on what we call the CalFuse framework. This was a framework for how we felt dynamic rates should be offered through the regulated utility companies. And since authoring that paper, there have been many pilots that have been initiated that have offered rates on a pilot basis based on the key elements of that framework. And at a high level, again, going back to the notion of cost reflectivity through rates, at a high level, what's been a key part of these pilots is that you send through a price signal that conveys the wholesale market price on a day-ahead basis, but also conveys through the price the value of capacity, not just at the generation level, but also at the distribution level. So what this means is that in some of the PG&E pilots, there have been circuit-specific pricing for the marginal distribution capacity cost. So the costs that are associated with expanding the distribution grid to upgrade that portion of the grid is then being shaped into a price component so that the customers on that specific circuit are seeing a price that's reflecting the congestion locally. So we view the value of not just a signal that conveys wholesale bulk system conditions, but also incorporates local conditions, because that combination of the two is really important as we try to scale up and increase demand, increase load, but in a way that is sustainable, so that there isn't an immediate rate shock through upgrades that impede the adoption of electrified end uses, and rather we provide signals that allow for a more scalable expansion. So the CPUC has authorized expanded pilots for both PG&E and Edison based on sort of the core CalFuse framework. And PG&E has already indicated that it has enrolled over 75 megawatts of customers in its pilots. And so that's very exciting. There's a lot of customers already signed up, and we're going to be getting a lot of results on that. And as soon as there's live applications in front of the commission for more permanent rate offerings. So we look forward to considering the applications and hopefully having those rates available on a more permanent opt-in basis going forward. So it's an exciting time on rate design at the CPUC. We really value providing access to dynamic prices, but also ensuring that all the rate offerings go in a direction where they provide strong incentives for behavioral modification and also appropriately recover costs from customers based on their demand patterns and their use of the grid system. Thanks.
Thanks, Achintya. Next, we have Keith Graeber from UC Davis. He's Engineering Director at the CLTC.
Hey, thanks for having me here. And yeah, it's warmer than it was before lunch, I think, right? It's not just because you guys are looking at me. So I'm Keith Graeber. I'm from the California Lighting Technology Center here at UC Davis. I'm going to be flying a little bit lower than I think a lot of my other panel members here are. And as we're an applied R&D group, and we pride ourselves on hands-on work and really interacting with the technologies that are here and now and available to the end user. So that's the perspective that we're bringing. For the past 4 to 5 years, we've been exploring the potential of smart appliances specifically to adjust their load profile based on a range of grid signals. And so I'm here today to share our experience in that space as kind of a super user. We often have to pretend like we're a customer unboxing these new technologies for the first time in order to even do the lab or field tests that we want to do. So we have a lot of hard lessons learned that we hope that we can publicize and evangelize and collaborate with our industry partners to minimize for the real world folks whenever these technologies reach broad adoption. And so my perspective on load flexibility for the residential sector specifically, because that's where we've been really focused. There's a few obvious pieces of low-hanging fruit, such as solar combined with stationary storage and smart inverters that also incorporate, bidirectional EV charging. But beyond that, it's kind of blue sky. There's lots of medium-sized appliances that are coming to market with communications built into them. And I think that, we have a lot of work to do collectively to figure out what that next tier of, not low-hanging fruit, but it's reachable, right, if we stretch. So I would, that's also to second Beth's comment about perseverance, I believe. I really like that, and I feel that. So yeah, we're gonna need to persevere in terms to determine the next opportunities with respect to feasibility and cost effectiveness.
Thanks, Keith. Next, we have Mitch Sears. He's the CEO of Valley Clean Energy. Go ahead, Mitch.
Thanks, Steph. And thanks so much for having us here today. So Valley Clean Energy, for those of you who don't know, we're a community choice aggregation program that serves load here in Yolo County dating back to 2018. And our experience with load flexibility and dynamic pricing dates back almost 5 years now. So Valley Clean Energy, along with some key partners like Polaris Enterprises, run by David Meyer, he's now running Grid Tractor, we got together and we submitted a proposal into the CPUC for a pilot program back coming out of the 2020 summer reliability proceeding that was in place at that point. And so out of that, what we tried to do is look at our service territory, because as a community choice aggregator, we're very focused on our customers. For those of you who don't know the CCA model, but basically our customers can leave. If we don't add value, if we don't provide a value stack for those customers, they can make a choice and go back to PG&E. That's just the way that the CCA model is set up. Proud to say that we still have 90% of our eligible customers participating with Valley Clean Energy. But one of the things that we try to do is identify what those customers might benefit from. In our service territory, agriculture, as you probably saw, either if you are from the area or driving in, agriculture is a big part of our service territory. About 85% of our service territory here in Yolo County is designated for agricultural use, whether that's row crops, orchards, grazing land. And that translates to about 15% of our overall load being in the agricultural sector. So we pay very close attention to that particular segment. So that sort of led us to try to come up with ways to add value out of this proceeding. As I mentioned, we helped design a pilot program, in part because those customers are also very cost conscious. And so we want to be responsive to them and sort of help them become more successful in what they're doing. And Bruce's team over at LBNL helped to reinforce that through some of the research that they did leading into that proceeding. They identified agricultural pumping load as being one of the most cost-effective and accessible load shifting opportunities in the entire state. And so we're confident, based on our pilot results, that that type of load shift in that particular sector, designed correctly from a customer perspective, can have a significant contribution to the state's 7 gigawatt goal by 2030. Based on the research from LBNL, we think that there is between 1,000 and 2,000 megawatts of shiftable load. The way that we like to talk about it internally is that all of us are standing on a giant water battery here in the Central Valley. It all depends on when that water is brought up out of the ground. So with that, just a couple of quick sort of points on the design of the agricultural irrigation, flexible irrigation technology, or AgFit pilot program, which is just actually wrapping up after a 3-year run. It was incentive-based, $200 per kilowatt for automation, basically allowing those pumps to receive a signal from Valley Clean Energy and our partners at PG&E, thank you, to be able to basically turn on and off based on hourly price signals. There was a good deal of customer support. I'll get into this in one of the slides, but there was software training, a lot of one-on-one sort of interaction with those customers to bring them along in understanding and confidence sort of where they needed to be able to feel like this was something that was beneficial to them. The price design, as Achintya mentioned, hourly, week ahead, and grid responsive. We'll see that here in just a second on one of the slides. There was bill protection that was incorporated in, again, to give the customer confidence to be able to participate in the pilot program. They never paid more than their otherwise applicable tariff or their blue bill. So basically, there was a little risk to them to participate in this pilot program. We found that after running the pilot program, there were other co-benefits that were associated with this, principally water conservation. Because for those of you who know the agricultural sector, there's not a lot of automation in pumping load, and having your irrigation manager drive an ATV 20 minutes across the farm to be able to turn off water when it doesn't need to be running, there are real opportunities for water conservation. There's also labor efficiencies. We also, as part of the CPUC process, incorporated in measuring results. So there was a midterm and a final report that was produced. And those are both, I believe, either published and online at this point in time. So a lot of good information there. But the basic premise of the pilot for Valley Clean Energy was, if given the right automation equipment and the price signal, would our farmers respond to those price signals? And the answer was a pretty resounding yes. If we can go to the first slide. So you saw a version of this in a previous slide, but basically this is the customer interface that our farmers saw. Across the top are the 7 weeks of the day. We gave them a week in advance forecast for where prices were going to be. On the vertical is the hourly. So we wanted to keep it as simple and straightforward, and I want to stress simple and straightforward is the key to this from a customer perspective, whether in the agricultural sector or anywhere else. But basically, green is good, the grid is not stressed, orange a little bit worse, and red, unless you absolutely have to, stay out of those hours. And that's the beauty of the price signal. And again, working with PG&E through the CalFuse model, we were able to take all the different components of the price that a farmer would see, generation, transmission, distribution, and put them into one price so they actually know what they're paying and can make informed decisions about whether or not to irrigate during that period of time. So this really was super important to be able to, and I want to emphasize, because we're talking about customers here, that simplicity was very important. And as we go into looking at other sectors, and Keith and his team and VCE are working on these types of things in the residential sector, that has to be front and center. Otherwise, if customers don't participate, all the policy discussions that we had earlier in the morning really fall on deaf ears. So this is really where VCE's focus is. Go to the next slide, please. So what we did is we built this on a three-legged sort of stool approach here. Sorry, I'm going to have to look at this. So we needed to send strong price signals with enough variability to be able to incentivize that participant to be able to say yes or no, and to make the effort to sit down and schedule out their irrigation blocks that we can advance. We obviously needed automation. Automation ended up being one of the primary findings of this, not surprisingly, but one of the primary findings is that automation is the key to any of this. That's making it simple and understandable, and sort of turn it on or set it and forget it. I mean, that's really kind of what it comes down to, where it works best. And then, of course, the outreach was critically important, and the support was critically important. I want to emphasize that for the room as well, is that without that, our participants are much less likely to spend the time and the effort when they have, I forget who said it on one of the earlier panels, but there's a lot of other things that folks are thinking about. We can't give them more additional complexity to be able to have to navigate. So we go to the next slide. Oh, I'm sorry, if we go back. So the basic results, and this is just from year one, and our results did change a little bit, but over on the left-hand side, the top is the year before the pilot went into play. The bottom is when we implemented the pilot. You can see the significant shift based on just those price signals. Now, what I want to emphasize here too, in the agricultural sector, there's variability based on crop type, on how much you need to water a particular crop. And in 2022, which is shown on the bottom here, it happened to be a drought year. So our farmers were paying twice as much water to lift the same amount, twice as much to lift the same amount of water out of the ground. So these things are going to shift around and change. But in a good water year, presumably there's more hydro. So this type of load shift may not be as important to the system as it is in these types of years. But that's, again, the beauty of this particular resource. We can go to the next slide. So here are some of the findings. I'm not going to walk through all those in any detail. It was a small pilot, but again, it answered Valley Clean Energy's question about whether or not this particular customer class would respond if given the right incentives to do that. We did learn that there was response outside of the peak window, which is a good thing as we move into sort of a different iteration of the grid going forward, depending on when the resources are available and when the power is being used. So there's a lot of flexibility here. And the nice part about this particular approach with pricing is that you can adapt. So if you've got a winter peaking load, you can adapt to that. If you've got a summer peaking load like we do here, we have a coincident air conditioning and agricultural pumping load sort of peak from a seasonal perspective. That means a lot to us because I and my team don't need to go out and buy as much RA if we're able to shave that peak. So I'll stop there. There's obviously a lot of expertise up here on the panel, and hopefully there's a lot of questions that are flooding in. So, Steph?
Yeah, we are getting a bunch of questions. I'm going to ask maybe one direct question, maybe not to everybody, but pretty much everybody, just because we ran over time a lot from what I was expecting. So, Bruce, can you talk a little bit more about what are your top priorities for building a system that provides load flex from prices and automating customer devices? And also, what are the biggest barriers to realizing that?
Again, the optimal building system is one that is the same across the planet. Ethernet switches and routers are the same everywhere because we have standard technology. The biggest two barriers I would say to moving forward, one is what I alluded to earlier is ideas that are now obsolete. Mitch mentioned demand charges as a problem in their case. Demand charges, for example, are a 19th century technology. They're 128 years old. We have far better ways to accomplish what they do than that. But probably the main barrier is the lack of prices. In my house, I have a heat pump and a very clever heat pump controller. It's a commercial product I have no involvement in. It is optimizing to hourly prices right now, and it takes those prices in over OpenADR3. And it got both of those capabilities with a free software update from the manufacturer. It did not have those capabilities when I bought and installed the product. But I can't pay hourly prices today. So once I can, then I can connect up to the PG&E price server, which also uses OpenADR3, and move to the better future. In other countries, like in Scandinavia, where most people pay hourly prices today and save money through it, they first introduced prices, and then after they introduced prices, automation began to spring up to use those prices. But manufacturers are not going to innovate into a vacuum. They're only going to put in capability if they will believe it will deliver value to their customers. So we have to have prices which are valuable to people because they deliver savings, and then manufacturers will build the automation and deploy it rapidly to cut to products so they can use them. So those are my top.
Yeah, thanks, Bruce. Relatedly, as far as rates go, I know PG&E is piloting highly dynamic rates, and those rates include subscriptions that are based on historical electricity use for each customer. As I understand them, it's going to be very, very difficult to figure out what price you are paying for electricity at any given hour, because you have to know your subscription quantity before you can figure out what your additional kilowatt hours are priced at. So, Jomo and Achintya also, can you tell us a little bit about subscriptions and why you chose them?
Yeah, this is getting into the weeds, but I think it's a little bit of a mischaracterization to say that your price depends on what your subscription level is. The idea behind the subscription, I'll try to make it as simple as possible. This is an idea that started in the early 1990s, when Georgia Power, the utility company that's been providing dynamic pricing for the longest time, has the most successful dynamic pricing program in the US, created a dynamic pricing program wherein the customer had what they called a customer baseline load or customer subscription. The idea was you have a historic load profile. That's how you've used energy in the past. We're gonna just have you prepay for that energy at whatever rate you were paying, and then anytime you deviate within any hour in response to the dynamic price, you pay for the deviation within that hour from whatever you were doing in the past. And this is a really important idea because I think going back to my original point about why do we do rates? Rates are not just price signals. Rates are also revenue recovery. They're a question of fairness. So how do you recover costs that may not vary with time from customers when you're on a highly time-varying rate? So you can do some combination of fixed charges, whatever, there's a variety of approaches. This is another approach. It also has the co-benefit of providing some stability to customers as they transition from a regime where prices don't change hour to hour to a regime where they do change hour to hour. Now, it's not a necessary feature. I think the way that it was described in the white paper that Energy Division staff put out it's an optional feature, again, highlighting that this is how the longest running successful dynamic pricing program in the United States has functioned. And so as we go forward to a transition to more dynamic pricing, it's worth considering what kind of seatbelts do we need to provide, right? Because at least in other European countries that did transition to dynamic pricing, and in, I think the most notorious example in the United States is in Texas with Griddy. What did happen was when there was a long-term price spike, in the case of Europe, when Ukraine was invaded, gas prices spiked for months at an end. In the case of Texas, there was Winter Storm Uri, prices hit their max for, I think, days at a time. What ended up happening was that customers who were getting a purely dynamic price with no seatbelts ended up being on the hook for a very high bill. Now, that, in the case of Texas, resulted in the state legislature disallowing dynamic pricing for most small retail customers. That's not an outcome that we want to go for. In the case of Europe, it required the state, the countries themselves, to step in and provide relief to customers. Again, not the ideal outcome. So the consideration behind the staff white paper was what are the kinds of protections that can be built in structurally that provide incentives, right? Because the idea is you have a certain load level that this is within a given hour. You use less than that, you get paid the dynamic price. You use more than that, you pay the dynamic price. You still face the same price. The price doesn't change. It's just your bill at the end of the month may be different, but the idea is that you protect the bill but preserve the price. That's the idea behind subscriptions and how they've been implemented. Now, that being said, there may be better options. There may be a better way to do that for smaller customers, and we're, I think, certainly looking forward to the ideas that come from the utility companies when they consider in their applications how to provide dynamic pricing at scale. Currently, in the pilots, the idea behind the subscriptions is implemented, but we've iterated on that. That's the whole point of pilots, to try out different approaches to see how different customers can both receive a price, but can also be able to be protected against events that they cannot reasonably shift out of.
Yeah, thanks, Achintya. I'm going to go on to Keith and ask a different question entirely. So, you've worked a lot directly with appliances that are capable of flexing load. Where do you see existing appliances working well, and what do we need to address to make sure that they get better in the future? What are the current issues with existing appliances?
Sure. I think for the future of load flexibility with communication, directly to the smart appliance, the appliances and the appliance manufacturers are doing a great job coming up with lots of amenity-based features that I think will probably ultimately transform the market much faster than a lot of the pricing structure and economic benefit that we're talking about month to month on the utility bill. So I think that's really important. We have to make the end users want these appliances for as many reasons as we can. So I think there's a lot of potential there in the smart appliance sector, and where we've had a lot of challenges and where we've had to put on our super user hats to overcome lots of unreasonable challenges that it's hard to imagine a regular person putting up with for very long, is just the fragility of the communication pathway to the appliances. I mean, there's so many widgets in between where the signal originates on whatever server it's coming from, and having it get all the way to either some intermediary controller or directly to the appliance. The ISP provided hardware, the homeowner adds networking equipment. After that, there's firmware updates, and there's a surprising amount of downtime in residential ISP in America, more than I expected, for sure. So there's just a lot of potential for ships passing in the night and not linking up, and so I think that's where we really have to figure out that's a big problem, and one direction to come at it from. The other direction to come at it from is to learn more about those types of barriers and figure out how to model it or predict where that is and incorporate that into how you estimate the value of that asset. And it'll probably end up being something in between.
Thanks, Keith. Jomo, you want to add to that?
So one thing I wanted to add to that point is that in addition to helping with the interoperability of the different devices in a premise, we really need better the flexible demand appliance standards effort is underway. We really need that. I'll tell you, the last 5 or 6 years, I've been working on a number of different programs and pilots, and with technology that maybe would enable automate technology and so on. The cost of communicating or sending a signal to the device, a lot of times, is way, way higher than the benefit we get from that device. So, device access fees, for example, have killed many programs that I've tried to work on, I'll tell you right now. So we need to do something around to get a handle on how do we actually make it easier for whether the LSC, the CCA, IOU, to communicate with the devices themselves. In addition to make sure the device, the technology for managing the devices, make sure that they actually can talk to each other works well too.
Thanks for that. So for Mitch down at the end, I'm going to paraphrase one of the audience questions here. So what strategies did you see as successfully improving customer engagement with the demand flexibility, both with your AgFit program, and have you seen things for other related programs, maybe for residential or anything, if you've worked on those?
They demanded more subscription pricing. That's what they wanted to hear more from. I'm kidding. That's sorry. Boy, this is a tough crowd. Yeah, I don't, do you want to repeat the question? I'm just trying to make sure sorry, there's a,
No worries. So,
Yeah.
you know,
what worked best?
yeah, what worked best to get people engaged?
Yeah, good question. It came down to affordability. I mean, it really came down to price. It came down to, as I mentioned before, sort of simplicity. I, myself, and Rebecca, part of my team, went out and worked with potential participants in the pilot, and our traction rate was pretty good, but it did take a lot of time to sort of handhold and work through this. But I would say that having the ability to show them what their potential savings were going to be, that it wasn't too onerous, because again, I mean, they're paying attention to a lot of different things here in that particular sector. So I would say that that's probably having a good idea going into it, what was going to be necessary to be able to have that conversation. One other thing I would point out too is that as a community choice aggregator, one of our, I guess, superpowers is to be able to have a relatively trusted source within our service territory. So we went into the conversations with the ability to say we're locally based, we're a public entity. Not that gets you too far in a lot of these types of conversations, but sorry not to throw PG&E under the bus, but right now the customers are very sensitive to a lot of these issues, and so having a different, I think, voice there helped sort of move us along, and having some of that sort of more localized knowledge, I think was helpful to us. Just if I could editorialize a little bit here too, I know we don't have a whole lot more time, but I do want to say from a CCA's perspective, this is a very important sort of area for us because it is a connection, a touch point with our customers, as you've heard me say. And I don't want to speak for all CCAs, but the 25 across the state that serve over 14 million customers here in California, about 1/3 of the customers collectively, we do want to make sure that the design of these flexibility programs treats bundled and unbundled customers, basically investor-owned utility customers and CCA customers, sort of equally and fairly. And as we go through sort of the design and the regulatory process, we just want to make sure that that voice is being sort of represented fairly. We also want to emphasize this idea of outreach and marketing, as I pointed out before, is that's one of the advantages that we hope that the state takes advantage of. And I heard it mentioned at the I think at the opening panel here today too, is that we tend to be a little bit more of that sort of trusted resource within the discussion, because again, this all turns on the customer participation. Without it, we can design everything we can, but it may not do that. Lastly, I would say that we're not looking at this as a sort of a one-off in this one particular sector. We obviously serve a lot of other load in a lot of different sectors. So we're working with Keith and his team at UC Davis to look at the residential sector, for example. How do we get into and make the vehicle to grid sort of component important to us? Because the last thing that we want to do as a CCA, again, our customers can leave. We don't want to head our customers down a dead end if the resources and the support and the design is not there. So that's why we're so deeply engaged in this and why we're happy to be here today talking about this.
Thanks, Mitch. I do also want to say, if you guys have questions for each other, that is okay with me. So I will keep asking, but and I'm going to bring in some of the things from everybody else here. But if you do have questions, go ahead and do that. Right now, I think I do want to ask, and I'm not exactly sure who is the best person to do this, but there's a question here, and there was a related question earlier that I saw come up, which was especially for the IOU programs or the larger statewide programs, there's a lot of choice in demand response, a little bit less in what I'd call demand flexibility. But what do you do to simplify this for customers so that they can understand what is available and what their choices are?
Yeah, so one of the benefits of being California is that customers do have a lot of choices and options for managing their energy. I think a couple of things that stand out to me from your question. One is that we need to get better alignment between the CEC and the CPUC on which agency will take a lead on different types of programs. Right now, we have some programs that basically duplicate each other. And so we have customers that are in an ELRP program that now are going to DSGS or vice versa. And so, that's fine from the customer perspective, they have choices. But the issue is then, that means that, one example, the megawatts that we rely on for resource adequacy, for example, are lost from a, utility program to a non-utility, non-market integrated program. And so the cost for us to acquire RA basically go up as a result of the lack of coordination between two agencies. So I think that's one issue we should do, one thing we should do. The other thing is, one thing we've done the last couple of years on demand response is we actually began to very seriously leverage our business account reps and marketing to actually, again, get in front of the customers and not only say, hey, this is a program you might like, but actually show them this is how you would benefit from the program. And I think part of the issue is that the way in which we sell the programs, the way in which we propose the value proposition, is done from the perspective of policymakers, from folks who are in technology, who have an interest in think they understand the benefit, but don't understand how people who are not in this world will, accept the messages, will actually respond to the messages. So I think the other key thing is then, how do we actually, partner with, other folks in industry, technology companies, and so on, to try to get a better sense of what the customer is willing and wants to do, and also how do we put in front of them options that they haven't thought about yet and show them the value that they could receive.
Yeah, I would just say that I think the ideal number of demand response programs that we have in the future is 0. For the most part, we only have demand response programs because we charge the wrong price for electricity, we get the wrong result, and then we have programs to value electrons differently from the price that we just sold it at the same place and time, which makes no sense whatsoever. So most demand response programs become obsolete, thank you, once you have good prices. Now, I would distinguish from that programs for facility people acquiring equipment or software that is price responsive. That's clearly distinguished from dynamic operation. And I think for things like emergency reductions and such, or there's maybe a role for programs, but for 90+% of it, we can do it all through prices and produce a better outcome for the customer and for the grid.
Thanks all for that. So let's see, I have one more that might be, let's see, trying to read these. Oh, right. So Keith, I know you've worked directly with customers, at their homes, at their businesses. What kind of feel are you getting, or what are you hearing from the customers when you're testing these devices? And I think most of the stuff you've done is used rates, but what are people looking for when they're installing flexible devices?
Well, most of the end users we've worked with are looking for the incentive that we offered them to participate in the study. And then they're also like, we're gonna get some free gear, right? Beyond that, there's not a lot of expectation because this is a very new, strange idea that they're being introduced to. And honestly, it blows me away, like how unengaged our study subjects normally are when we're in their homes, like messing with all of their stuff. I'd be freaking out, right? Like, but there's keys to the castle. Let us know when you leave or not. We don't really care. It's been eye-opening to me just to kind of learn more about how everyone else lives, I guess, than the study subject that we're focused on. But I would say what has surprised me the most about the end user response and the load flexibility studies we've done specifically with end users is how open they are to it. We always accompany our technology deployments with qualitative web surveys, and quite often we're finding that we have over-incentivized the study subjects to participate by like orders of magnitude. When we ask them like, did you notice this? More often than not, yes. Do you feel like you need to be compensated to experience that in the future? No, not really. So I think that's kind of been what has surprised me the most in interacting with folks in their, real world folks in their homes on a regular basis. I think that there is a lot of that worry in this space that it will be fully rejected because everyone wants full control over everything that happens in their home, and I'm not sure that that's true. But yeah, we certainly need a lot more data in that space, but those are my preliminary findings are folks are a lot more open to this than I would have guessed, which is good.
Great. Anybody else want to respond if you've had direct contact with customers?
I think you've heard me sort of talk about that, a fair amount, but I would say that, again, from our perspective, because this was in a sort of a business setting, it really came down to affordability and simplicity. Just didn't make their life harder, and they were able to see a benefit that came out of that. And I think that based on our experience in our pilot, those objectives are achievable. So.
Excellent, thanks. So did my bid for questions from the panel elicit anything? That's a big no. Okay. We got time for, I think, one last question here. I got a couple minutes left. So one of the questions out there is, with Bruce's point about not making this too complex, but the reality is prices or programs and prices need to be responsive to the situation that the customer is in. Is there, and maybe Bruce, you're a good person to start with this, like, do we need different rates for different types of customers in, beyond just like residential, industrial? Can we value demand flexibility with rates effectively? In order to do that, do we need to talk about rates for EVs or rates for somebody with EV? Like, a lot of these things are available right now through PG&E and other IOUs. They have rates for different, an electrification rate, an EV rate. Do we need those different rates?
I would say in general, no. I work at a physics laboratory, and my colleagues assure me that all the electrons are the same. When I go to the store and buy tomatoes, I don't get asked, am I making pasta or salad, to be a different price. They're just tomatoes. They're just electrons. Now, there's possibly a limited role on a very short-term transition basis for having, let's say, hourly prices for one end use and then TOU for the rest until you move to complete hourly. But anything like that should be understood to be limited and not a permanent state of affairs. And the internet protocol, internet technology is the same for all customer types everywhere. It's universal, and pricing can have that same characteristic. We do not need different prices for different people of the same customer type.
We got a couple more seconds. Anybody else?
Yeah, sure. I mean, I think I'll just stress again, right? I mean, because the price is how we recover, costs from people. That's like an important part of the price. So once you start creating prices that are different for different end users, somebody else is picking up the tab for you, right? And I think that's the question of fairness. I think generally speaking, the question of customer acceptance is sort of a tricky, almost unknowable thing. And it may be worth for us to look carefully at what other countries who have similar conditions, more variable resources in the grid, increasing electrification, what they're doing. And it does seem that the trend is, if looking across the Atlantic, a lot of countries are going towards more dynamic pricing because of a variety of reasons, not just, again, the potential for load flexibility, but also, again, because if you have to recover costs fairly, perhaps the price should reflect that.
Yeah, thank you. And that's it for the panel today. Thank you all very much for participating. Thanks for the good conversation.